All right, everyone. Welcome to another episode of the TWiML AI podcast. I am, of course, your host, Sam Charrington. Today, I'm joined by Miriam Friedel. Miriam is a Senior Director of ML Engineering at Capital One. Miriam, you joined us for a panel at our last TWiMLCon conference, and I've been wanting to get you on the show ever since. I really enjoyed hearing a bit about your story and some of the insights you shared into creating organizations that retain some of the desirable characteristics of startups, but in larger, highly regulated environments. So welcome to the podcast.
Thank you so much for having me, Sam. That was a great panel. And I always love speaking on things like that because I learned just as much from my co-panelists, Rosa and Adrian, as I do speaking. So it was awesome to be on that panel. And thanks for having me on the podcast.
So you started your career as a theoretical physicist.
I did, yes. I did start my career as a theoretical physicist. I got my PhD in 2006, which is a little crazy to think about it because in grad school, it feels like it's going to go on forever. And suddenly you blink and it's 17 years in the rearview mirror. But I studied protein folding. So I was using the techniques of computational and statistical physics to understand how proteins fold and aggregate. So it was a lot of, obviously understanding math and physics, but it was also take this equation, take this concept, put it on a computer, make sure it's correct, run some experiments, write some papers, get a PhD. And as it turns out, that notion of are you calculating what you think you're calculating? Are you really sure about it? Is actually relevant to my job today. So let me tell you a little bit about the story of how I got from there to here. After grad school, I really didn't want to be a professor. It's an amazing path, but it just wasn't for me. So I went to work at a consulting firm. And that's where I like to tell people that I learned how to write software properly. I learned about version control and I learned about object oriented programming. And I learned all of those things that I didn't learn when I was a self taught theoretical physicist. And I also learned how to ask the right business questions and interact with clients, all that good stuff. After that, I went to work in a neuroimaging lab, which was a little bit of a detour back to academia. But in the neuroimaging lab, I was doing a ton of Python programming, R, statistical analysis, doing a lot of analysis of the scans. I worked at a place in Toronto called the Mouse Imaging Center. And so it was trying to understand how mouse genotype impacts phenotype and how we can use that to understand the human brain. So it was really fascinating. It taught me a lot about new programming languages, Python and R, which are pretty prolific in machine learning, and really got me back in the mindset of thinking about and dealing with data that way. So when I moved to Charlottesville, Virginia, where I now live in 2014, that's where I really got into data science and machine learning. I worked at another consultancy here in Charlottesville, first as an individual contributor, then as a people leader. Then, as you noted, I was head of data science at a startup before coming to Capital One in July of 2020. I now lead a team of about 70 engineers, machine learning engineers. And what we do is we build out tooling, Python libraries, Kubeflow pipeline components, template workflows to help the data scientists at Capital One build and scale their models more effectively. So that's sort of my story from theoretical physics to Capital One today.
Awesome. Can you elaborate on your role at Capital One? And in particular, I've interviewed one of your colleagues, Ali Rodell, who also works on platform there and Kubeflow. How does what your team is focused on differ from what some of the other ML engineering teams are working on, such as Ali's?
Yeah, that's a great question. You've actually interviewed a number of my colleagues, Bayan, Disha, Ali. So I should comment that I'm very fortunate to have such an amazing set of colleagues to work with and to learn from. So as you noted, Ali is building a platform based on Kubeflow. And for those of your listeners, you can go back and listen to that podcast. And so he's really making sure that we have the right foundational infrastructure. My job is sort of serving as the interface between his engineering team and our customers. And there's a lot of collaboration and partnership that goes on there as well. So here's an example of the types of things my team builds. When you think about the model development process, one thing that is really important is experiment tracking, particularly in a highly regulated environment like Capital One. So, for
Hmm.
example, when you're training a model, you're going to go through a number of different iterations. What hyperparameters did I use? What features did I use? Maybe what was my F1 score for that run, or what was a particular loss function? So, being able to track the results of those experiments is something that is really important to us as we train models. And so when we built this software, it's called Rubicon. We didn't have the plethora of really good tools that exist on the market today. So we
Hmm.
found we had a need and we decided to build something to meet that need. And as the tool itself evolved, it's a Python package, we thought, hey, we want to contribute this to open source, and we want to contribute this so it can be one of different tools available in this space. Probably some of your listeners are familiar with things like MLflow. So another thing that we build is Kubeflow pipeline components. So a lot of the data scientists that we work with are not super familiar with Kubeflow, with how it works, right? Like there's a little bit of overhead for building out some of the orchestration code. So one of the things that we're trying to do is make that easier and build template components that our data scientists can use, can pull off the shelf, and make it easier for them to run on Ollie's platform. And I'll provide one more example that sort of is at the intersection, I think, of the libraries and the components and how we pull them together. So, as one example of the tooling that we provide is when you think about analyzing the results of machine learning models, you need to look at a lot of plots, right? So you can see what is my data doing, right? Like what does it look like? And so sometimes when you generate these plots, when you think about things like Shapley values or partial dependence plots, which gives you insight into what your models are doing, there's a little bit of calculation that you have to do on the back end in order to generate the plots in the format that you want to see. And so this is really important for our data scientists as well. And it's important for us also because of our model risk office, which is something, I'm sure we'll talk about in this conversation, making sure that we're presenting data to them in a way that they need to look at to validate our models. And so we found there was a ton of duplication around Capital One, sort of this arbitrary, continuing to build out these plots sort of uniquely across all these different lines of business. And we said, there's a real opportunity here to consolidate, the plotting and um, the calculations on the back end, right? So you don't, if you need to calculate a partial dependence plot or a Shapley value, you don't need to have, 14 different copies of your code doing this. And similarly, when I think back to my days when I was doing data science, I felt like every single time, you think about Matplotlib and Seaborn, and they're such like powerful libraries, but every single time I would need to like, what is the syntax? Oh, my x-axis is not formatted properly. Oh, the tick marks are the wrong size. Oh, it's the wrong color. And so when we think about the reports we have to generate, sort of pulling all of those things out, creating a standardized plotting library, and then also creating components around it. So when you think about running a pipeline from end to end, being able to sort of automatically generate these things is maybe a last step in a DAG. So these are the types of tools that we are building in order to enable our data scientists to leverage the platforms that Ollie and team are building.
Hmm. Hmm. There's a lot in there that I want to follow up on, but the last thing you mentioned, that last example, kind of prompted a thought. It's
Uh-huh.
maybe going off in a different direction, but a lot of the work that ML engineering teams like yours has historically done is like creating these tools and libraries so that teams don't need to build boilerplate,
Yep.
code as much. Um, but more recently we've got the rise of things like Copilot and
Yep.
LLMs applied to code generation, which also solves a similar problem. Like
Yep.
you don't have to think about you just put in the comment the kind of chart that you want. You don't have to think about
Yep.
how to get the tick marks correctly and all that kind of stuff.
Yeah.
How do you see those tools impacting the way you approach and prioritize projects for, for your team? Like, are you there yet?
So we're obviously thinking about it, right? Like I think
Yeah.
anyone in this field right now is thinking about what's happening, with Copilot, with GPT-4, with all of the amazing tools and the advances we've had in generative AI. The way I think about it right now is a little bit different. And actually, this is a good opportunity for me to talk about our model risk office, which I've already alluded to. So,
Mm.
many companies like Capital One, which are really large and highly regulated, have a model risk office or a similar function. To make sure that we're in compliance with any applicable laws and regulations. And so it's really important for our data science population to be able to clearly articulate to the model risk office, through code, through white papers. They have to write white papers, some of which, by the way, are longer than my PhD thesis, explaining why. Yeah, it's incredible, like how long and detailed they are. But explaining, why this particular model, what is the business problem we're able to solve, and really providing like a level of transparency throughout the entire model development lifecycle. So I think that as we start to think about how can we effectively leverage tools like Copilot, right, to take away some of the challenges with building boilerplate code or making our development process easier. I think certainly from our standpoint as a highly regulated organization, we still need to be able to make sure that we provide that transparency to the model risk office to make sure that this is safe, this is secure, and making sure we have the right guardrails and testing in place, which we do right now for all of our libraries. Getting back to that question of, are you calculating what you think you're calculating? Like, are you sure that math is right? So I think we have to find the balance there, and it's definitely a really exciting space to be in. So definitely we're thinking about it, but we don't have a specific, direction that I would, want to dig into at this point. So
Yeah. Well, a bit of what I heard there is that beyond eliminating, repetitive boilerplate code, a lot of what you're trying to do is to encapsulate aspects of calculations that are easy to get wrong
yep,
and offer folks kind of a proven way to incorporate those into their models. And so, um, introducing a degree of randomness through code gen is maybe the
yeah,
wrong direction relative to what
yeah.
your goal is.
Yeah. And I think what you said is, the things that are easy to get wrong. So, as
Yeah.
an example, I don't know, I want to say a year ago, I was looking through some of our GitHub repositories. So, Capital One is a really big place. And there's a lot of big companies like Capital One where you have a ton of really smart people doing a lot of innovation. And it's kind of impossible to be able to know all of the little pockets of innovation that are happening. And in some sense, that's like a really good thing, right? Like we get
Hmm.
to build really excellent stuff, and you don't know where you're going to find it. The flip side is you don't know where you're going to find it. So about a year ago, I was looking through our GitHub repositories, and I found like maybe at least 7 different calculations of the population stability index, right? And I was thinking to myself, like, okay,
And
these
what's
teams
that index?
so the population stability index is a statistic that measures how much a particular variable has shifted over time. And so you use it to measure the applicability of a certain statistic to your population, right? So it's
Okay.
in and of itself, it's not, you know, anything particularly crazy, but every single time you write that code to do that calculation, you introduce the possibility of an error. And so if you can have like a centralized location or a centralized tool that people are pulling from, then that's going to reduce the possibility of error. So if you think about something like scikit-learn, scikit-learn is used very widely in the open source community. We use it, we love it. There's a lot of great open source tools that we rely on. But because scikit-learn has such a robust community of users, people trust it, right? And people are gonna pull from it. And so really we want to try to build out that level of trust with our users, leveraging open source, but then adding in the things that we need to that are maybe specific to Capital One's needs.
Hmm. Hmm. Um, this model risk office has come up a couple times already. And I think of it as kind of representative of this broader function of operating in this highly regulated environment. And, that's very different from when you were running data science at a startup. Like, talk a
Yes.
little bit about I guess I mentioned this in an intro. Like, one of the things that came up in this panel that we did is like, how do you retain agility and speed and some of the characteristics that like we admire about startups, but
Yeah.
still operate in or under the constraints of an enterprise like Capital One. Like, how do you think about approaching that challenge?
Yeah, that's such a great question because it's really hard. But there's ways to do it for sure, and there's a lot to unpack. So first of all, when we think about like, I did come from a startup, and at one point the engineering and data science team all together was maybe like 10 people. So we had one stand up and one planning session, and it was really easy to know what was going on. And sometimes we would merge pull requests, and you would just yell to the other side of the office, okay, I merged that, try again, right? Which you obviously can't do in a company like Capital One, where we're spread across the whole US, multiple countries. So I think, discoverability, as I've talked about before, is definitely a challenge. I think another thing that happens in startups, which is hard to do in Capital One, and that's a good thing, is in startups, it's easier to just, I'm going to spin up an S3 bucket and I'm going to get access to, some example data, and I'm just going to go. And at Capital One, we take data privacy very, very seriously. And so access is much more limited, which is a consumer of financial products in this country, right? Like I think is a good thing, right? Like I want to know that as a consumer, my data is protected. So that's another element, is just, data access. And then I think, sort of retaining the agility in such a big environment. So one is, we're all aware of the model risk office. And so we know uh, that we need to incorporate that interaction into how we build models. And so I think knowing that from the get-go is really helpful. And I think really for me, what I've found is you want to give your teams a sense of the big picture. What are the broad, sometimes even company level strategic initiatives? What are the strategic initiatives for our division? And then sort of laddering back that back down to your team. So when you're within your team, you have a clear sense of ownership and responsibility, but you sort of know your swim lane so you can iterate in that space. And then since you have the ability to do that makes you go a little bit faster, because the overhead of communication is incredibly necessary, but it takes time and it takes thoughtfulness. So really finding that right balance between, hey, I know what I own on my team, I can iterate, I can work quickly with my peers, but I also know how that ladders up to the big picture. So I know if I'm stuck or if I have a really good R&D idea, I can maybe reach out to a collaborator, on Brian Bruce's team, right? He's our VP of applied research. I know you've spoken to him a couple times, right? Like, how can we make that happen? So I think it's really a mix of transparency, communication, clear ownership, but it's definitely like it's a challenge for sure. It's a good challenge, but it's a
Yeah.
challenge.
Yeah, historically, one of the challenges for MLE organizations is you have these great ideas for tools. You build the tools, maybe in partnership with a customer, and then there's this chasm where you want the broader organization to adopt these tools, and there's often a lot of evangelization that needs to happen. And
Yep.
it sounds like in your case, and this is likely representative of what's happening in other enterprises as well, that the MRO, this model risk office, is a little bit like a carrot and a stick. Like,
Yep.
if you use our tool, it's going to be less painful down the line when you need to, demonstrate that your models are, within spec, compliant, whatever the right terminology is. Or conversely, if you don't use this tool, it's going to be a lot more painful
Yeah.
down the line. Is that the case?
Yeah, so the model risk office actually can't be overly prescriptive, right? Because
Okay.
they are supposed to be sort of like an independent auditing function, but they can certainly say like, hey, for this particular use case or for something similar, we saw that this tool was really useful. Like, can you explain a different choice? And it's entirely possible the data scientist will say, yes, I had to use something different, and here's the reason why. And so then,
Hmm.
that's definitely fine. But the model risk office, even though it is a carrot and a stick, but they also need to maintain sort of, independence and auditability. So there's that as well.
Hmm. Hmm. Um, Kind of the flip side of, on the one hand, there's getting the teams, your customers on board with, might feel like to an engineer hoops that they need to go through, and all they want to do
Yeah.
is like deliver their perfect shiny model.
Yeah.
And we've talked about some of the ways you overcome that. The flip side of that is you're building tooling that enables folks to do these things that kind of aren't necessarily only around delivering functionality, but they're around robustness and compliance and all these other things that um, are maybe less shiny. Like, how do you from like a managing up perspective, like how do you justify the investments in robustness and um, tooling that uh, doesn't necessarily tie to business outcome, or
Yeah. So
maybe
that's a
maybe
great
the answer is actually that it does tie to a business outcome, but it's more nuanced.
Yeah, I think that's exactly right. It does, but it's more nuanced. So what is like, managing risk, right? So that's
Hmm.
one particular way. But the other thing is enabling, being able to use a standardized set of tools and contribute back to them, right? So we have a system, we have a data science and machine learning are filled with really creative, innovative people who like to build things, and that's how they
Hmm.
understand things. So it's, hey, we're creating this functionality that is going to serve your teams. They have the opportunity to contribute back, which then expands their influence, right? Because it's not just you're making an update that is useful only for you this time, but it can make somebody else potentially faster, right? So there's a time to market aspect where if you don't have to spend a lot of time worrying like, do I have the right Docker image? Do I have the right dependencies, right? Like, is this, this notebook that was written 2 years ago, is it still going to work on our current infrastructure, right? So having a centralized team to manage that and to take away these headaches really frees up the lines of business to think more creatively or maybe in a different way about the actual business problem they're solving. So instead of having to deal with, does this functionality exist? Do I need to rewrite this software? This package from several years ago is using an outdated version of Python, and now I have to spend a bunch of time updating it, and now all my dependencies are broken, right? Like, if we can help take some of that away, I think it actually enables, that standardization really, instead of inhibiting creativity, I think it can kind of unlock it for the data science population. So I think that's how, when we talk about managing, expectations sort of with senior leadership or with some of our customers, it's really about reducing risk and enabling them to work a little bit faster and in a more streamlined way. Um, so I think it's really interesting because you don't, I think it's like when you have like too many choices, it's almost like paralysis. Like, I think, when I was thinking about earlier on when I was in this field, just wanting to try everything and have the ability to do absolutely everything. And I can use, any Python library and any, or any R package. And then eventually, you have 400 things, and it's like, well, actually now it's too many things, right? So striking that right balance between giving people the ability to be creative and innovate, but also guiding them a little bit and taking away some of the pain points.
Hmm. Hmm. And I guess I'm curious, are there examples that come to mind that really illustrate like, you know, that tension and how it gets resolved?
Yeah, that is a great question. I think so. You're talking about the tension between like, I want to be able to do everything, but like, help, now I have too many things and I need
Yeah,
I
yeah.
need some guardrails. So I think one example is hyperparameter optimization. So there are a
Mm-hmm.
number of different like great packages to do hyperparameter tuning on the market. One example is HyperOpt. Another is Optuna. There was actually
Mm-hmm.
an interesting paper that came out last year that was comparing different techniques, and the punchline was depending on the data and the problem, one or the other might be better. But these
Mm-hmm.
things don't necessarily have a common API, right? So if you're a data scientist and you want to experiment with both, you might have to do a bunch of rewriting or sort of data manipulation because they don't have a standard API. So one of the things we've actually done in one of our libraries is provide this. So if you're doing hyperparameter optimization, creating a common API so you can use one or the other of those things. And so as we think about different hyperparameter optimization strategies, I don't think we need to give people like 100 of them. I think we can give them maybe 3 or 4 that are thoughtful, that meet a majority of the use cases that we're seeing, and then wrap them in a common API and a common suite of libraries that work really well together. So we can say, hey, you have the opportunity to choose and experiment with different hyperparameter optimization techniques, but you don't need to worry about everything under the sun, right? Like start here. And then we also really try, I think, as I said before, to create a culture of inner sourcing so people feel empowered to contribute back. Like, hey, I tried HyperOpt and I tried Optuna and they didn't really work, but I tried this third
Mm-hmm.
thing and I'd like to contribute it back. So now it can be part of your ecosystem and your suite of tools. So I think that's one example we found where, there's a lot you can do in this space. And so we're starting with Chew and it might grow. I think we also have some Bayesian optimization techniques as well
Mm-hmm.
in there. So really, starting small and then growing. Does that answer the question?
In the context of hyperparameter optimization as well as experiment management, you kind of alluded to, there are things that you built. In the case of experiment management, you built a tool. You might not do the same thing today
Mm-hmm.
because the market has matured. I
Yep.
hear that a lot about experiment management in particular. Like a lot of
Yeah.
ML engineering organizations, that was their first project because there was nothing good on the market, and like they
Yep.
wouldn't do it again necessarily.
Yep.
You mentioned the same thing around hyperparameter optimization or something similar. Like I'm wondering if you can speak broadly to the way you think about build versus buy. You've it's been a bit of a theme that's kind of been woven through some of the conversation,
Yeah.
but I'm wondering if you can speak to it more directly.
Yeah, that's a great question. I think with build versus buy, and this is something that I've had to learn this lesson throughout my career, is that when you choose to build something, there is a cost to maintaining it. And so
Hmm.
if you're going to build something, you have to think about, is there really truly nothing either as like a proprietary off the shelf tool we could use or something in the open source domain that we could use,
Hmm.
because if you're going to build something, you're then going to have to maintain it. You're going to have to think about things eventually when something better comes along. You're going to have to think about deprecation, right? We all
Hmm.
know that there's sort of like a life cycle to software engineering. And so I think, when I think about build versus buy, really the first thing I encourage my teams to do is look and see, does this already exist out there somewhere and can we use it? So with the example of Rubicon, right, it was something that it wasn't available when we started building it. So we built something to meet our needs. And so I think, step one in any build versus buy decision, I think, is what is available in the open source domain or in what are the options there, and can we use it, or can we build some sort of extension of it that is beneficial? I'm not a fan of like, let's wrap something for wrapper's sake. Like, right. Like I talked about, this is fun. Let's build it. Right. Like we're technologists. We like to build things. It's fun.
Hmm.
But with like HyperOpt and Optuna, right? Like we saw an opportunity there because it was a way to reduce, some friction for our data scientists and create a common API that didn't exist. So I think just being really thoughtful about that decision. And then for us, certainly, like, are there things that we need to do at Capital One that need to remain proprietary? And so then we have to say, like, can we extend what's available in open source, right? Like finding the right balance. But I think it starts with I talked about this a bit about building like a culture of collaboration and making sure that people can find things. I think one of the important things in the build versus buy decision is that people feel empowered to not build something from scratch or say, hey, I'm going to use something that exists, right? And I think, I've seen this in a number of different companies as well, is incentivizing reuse, right? Like we don't necessarily want our software engineers to write thousands of lines of code that are unnecessary. And so I think part of the build versus buy decision is freeing up your teams to make sure that they know they can do one or the other. Like it's okay to not build this from scratch. But I think really for me, when I think about that decision more and more, it's what is going to be the cost of maintaining this if we build it? And is it meeting some type of unique need that can't be found anywhere else? And then, of course, because Capital One is highly regulated, thinking about, that as well.
And have you found that it has become easier to kind of fully wrap your arms around kind of this long-term maintenance thing? It seems like that's like really hard to get right and probably frequently underestimated.
Yes, and I will say I'm kind of bad at it because I come at this not to be totally transparent. Because I'm a scientist at heart, right? And when I think back to my grad school days, long-term maintenance, like that's not a thing, right? Like maybe if you're lucky, someone else will use your code. And I want to be clear. I think the field has advanced a lot. I was in grad school 20 years ago. I don't think Git even existed yet. So I think that things have certainly evolved, but just even the notion of like, I'm going to put something in production or, this model has to have a millisecond SLA or whatever it is, in order to, if it's a transaction fraud model, for example, like those are not even things I thought about. So I think, for me, the fact that I'm on this podcast with you, even, talking about we need to consider engineering resources and all of this is an evolution in the right direction. But I think this also speaks to what's really great about this field is you bring in people from all different backgrounds and they all bring different perspectives to bear, because taking ML or AI models and making them really useful, I think is probably, you and many of your listeners know, it's not just about the model development itself. It's about everything around it. And one of my favorite papers is Hidden Technical Debt in Machine Learning Systems. I think it is now 10 years old, which is somewhat mind-boggling, but there's that picture and it has all the boxes, and the box in the middle with the actual modeling is like the tiniest one, right? And I think that even though we've obviously made a lot of strides as a field in the last 10 years, I think that there's still something to that.
Yeah, we had a little bit of an inside joke following our first TWiMLCon conference, which was 2019, I guess. Essentially, all of the speakers within their first 3 slides had that picture up.
Yeah.
Because the conversations were all focused on productionalization and MLOps. Yep. And it was one of the first conferences really taking on that topic. And that paper was such a touchstone for everyone.
Yeah. I've definitely put that image into talks before as well. But yeah, and it is also interesting thinking about, where MLOps is today versus 10 years ago when that paper came out. And I remember my first machine learning project, right, when I was working as a consultant, right, and we were building it was for SolidWorks. So the company I worked for was called Elder Research, and this project was for SolidWorks, which I can talk about because it was on our website as like a sort of joint success for a while. But what the company wanted to do was understand their user population, not through sort of traditional marketing metrics, but through how they actually used the software, right? Like what were people clicking as they use SolidWorks, which is like a CAD, like a computer aided design tool. Yeah, exactly. And, so we built this model for them, but we were so focused, we were a new team and we were so focused on getting the model right and really providing them with the right user segments that we did not think about operationalization, right? Like how are they going to actually use this model, right? And so, that was early on in my career as a data scientist. And so now, of course, I would think about the problem much differently. When we were able to operationalize it, we had an awesome, an awesome relationship with that company through several other projects. But it's really interesting to me now when I think back on it that like we were not focused on the operationalization piece. And I think part of it was we were a young team. And I think part of it was just where the field was at that time.
Mm-hmm. Mm-hmm. Kind of continuing on that theme of evolution, and you also just mentioned one of the great things about the field is that you're bringing together folks from various backgrounds. A recurring theme in thinking about kind of the way MLOps has evolved is that just the perspectives of the, who the customer is, meaning, I don't know, 5-7 years ago, the customer was a data scientist. They were very focused on, statistical modeling and really didn't want to think about anything else. Now, while they may not, be Kubeflow experts, you're kind of exposing them to some aspects of that. They have to think about version control to some degree.
Yep.
Kind of characterize that evolution from your perspective at Capital One and like where things are now and, how you see MLOps continuing to evolve.
Yeah, that's such a great question, and I think I'll actually tackle the second part of the question first. Is how will it evolve? And
Mm,
I think it's going to evolve in ways that we're still learning, especially with Gen AI and thinking about broadly building models using various LLMs, Llama 2, GPT, whatever you're using. The way that we need to do operationalization around that, I think, is going to be a little bit different from how we do it from more traditional ML models. And it's funny, I'm still
mhm.
looking for the right word, Sam, to describe these models, because I don't know that traditional is the right word for like XGBoost. Like, I don't know how traditional that is. But
Yeah.
anyway, so I think it's an
Legacy.
exciting, yeah, legacy maybe. But it's an exciting time to be in the field, right? Like to think about that. As far
Hmm.
as evolution, I think that the field is going to continue to evolve because if you think back maybe 10 or 15 years, SAS, which is a great tool, I think it was much more prolific than today, where I think today open source, people reach for open source libraries far more frequently. And so with
Hmm.
that, I think there is an understanding among practitioners that software engineering skills are going to have to evolve. And so as exactly as you said, we don't expect a statistician to be an expert at Kubernetes, but making sure it's finding the right blend of skills that you need to do your job and then making sure that you have the right partner teams for the skills that you don't have. I was talking with one of our customers the other day, and my customers are not Capital One's external customers, but they're the data scientists that are in our different lines of business. And I was talking with one of our customers, and he was we were talking about the practice of data science still in many ways is a scientific practice, and so finding the right balance to make sure that your teams are continuing to upskill, right? Because we can't just we're not relying on closed or COTS tools anymore. We are relying on open source, and that requires a familiarity with GitHub, with how to do version control with Python, but still allowing experts to be experts in their fields, right? If you take a
Hmm.
statistician or you take a data scientist who's really well trained at thinking through the theory or the nuances of different models, you don't want to make them become a Kubernetes engineer. So I think it's a real
Hmm.
balance between the field is going to continue to evolve, and we all have to keep learning, but not expecting every single person to be an expert in every single thing. We talk a lot in this field about unicorns, which is generally a term I don't like, but one of the great pieces of advice I got from a former boss said, you want to build the team that's the unicorn. And that has always stuck with me, right? Is
And what did
bringing.
that mean to you?
So what that means to me is you can't expect any one person to know every single thing, right? Like that's
Mm.
not realistic. And so when you think about building a team, you might want to bring someone who has a really deep background in software engineering or who is an expert in Kubernetes, who can really handle all that stuff deep in the stack. And then you might want to hire someone with some type of science PhD. And obviously I'll call out my own bias here because I have a science PhD, but like, so let's call that out. But but that's a different type of training and a different type of thinking in terms of how you tackle tackle problems. You might also want to hire someone that has, a degree in data science specifically, or a statistician, right? Or someone who is an expert, in DevOps or MLOps, right? These are all extremely complementary skills. But when you peel back the layers of the onion, there's also a level of specificity and a level of expertise you need in each thing. And so when I think about building the team that's a unicorn, it's pulling together people with all of these different skill sets who know how to work together and communicate with each other, and everyone knows the value that everyone else brings to the table, right? Like nobody knows everything and we're all learning from each other. And so I think in that way, when you bring together those skills and you create a culture of openness and communication, and you allow people to be wrong and make mistakes, and like that's okay because that's how we learn. I think when you pull all these things together, to me, that's what it means when you say building the team that is the unicorn.
Interesting. Does your team also work on productionalization efforts, meaning data scientist has developed a model, the model kind of works, and now it needs to be integrated into some business application or system or workflow, or is that a different team there?
So the way Capital One is structured, that is a different team, although we do
Okay.
work with those teams, right? So our data scientists also have partner tech teams, and I sit in the enterprise at Capital One. So all, the whole enterprise basically is our customers. But
Hmm.
that can be like, depending on where you are, you can have a different organizational structure, or your teams might be structured differently. So in some companies, right, you might have little pods throughout the company. So it's possible that a team like mine would be partnering with the data science team to operationalize these models. I think there's a lot of different ways that you can build successful organizations and successful organizational structure.
Interesting. I think one of the things that I wanted to ask you, and it's along the same line. So if it's repetitive and doesn't kind of bring forth any unique takes, let me know. But another dimension on this kind of startup versus enterprise is products versus projects, I guess. Like at
Hmm.
a startup, you're often thinking about building a product, and I guess in enterprise environments, often you're thinking less like, and as I'm saying this, I'm realizing I'm vastly overgeneralizing to make the
Yeah.
point, like, because I know within enterprises there are product managers and all this kind of thing, and that
Yeah.
that product oriented thinking has been making
Yeah.
its way into the enterprise over the past 10 plus years.
Yeah.
But I'm wondering if that, if anything jumps out at you in from your experience and um, you know, bringing that product orientation to the enterprise environment.
Yeah. So that actually is something that I have taken from my time at a startup, is that product minded thinking and bringing it
Okay.
to Capital One. But I have a very awesome set of product partners. And it took us transparently a few reps to get here, for a couple of reasons. I think one, the product mindset, again, when you take a bunch of data scientists, it's sort of not a natural mindset. And so we've needed some product partners to help with that. The other thing that is both fascinating and challenging in this space is building a product where your product is a library that calculates a bunch of different types of model interpretability, or extends a recursive feature elimination algorithm that comes out of scikit-learn, which is also something we have. That's a very different type of product than like Instagram, right? Which obviously there's machine
Yeah.
learning in Instagram, but the way that you think about your customer is different. And our
Hmm.
customers are data scientists, right? And machine learning engineers. And so understanding their needs and being able to gather requirements, I think it's in my opinion, which again, my product development experience is very limited, so no, this is coming from a scientist. It's just a different way of thinking about product development. But we have a really, really good team. One of my product partners himself has a PhD, right? So he brings like a really interesting, set of skills to bear. I have another one who's been at Capital One for a really long time. And so he is exceptionally good at understanding some of like the regulatory and risks, and some of the requirements we need to build into our tooling from that perspective. And so I think that like having that product development mindset has been really, really helpful in helping me to focus my team on delivery and making sure we're capturing customer needs in the right way. But I will say it was not a natural evolution for me, right? Like it took some thought and some care to get there. And some of that came from my time at a startup because, you at a startup, you have to move really quickly, as because you have a limited runway and, you might go out of business. So you have to innovate and really be so customer focused. And I think bringing that to Capital One and doing some reps with our current product team, I think it's been really helpful, honestly, in helping us to build better tooling.
And so try to capture the essence of what has you so excited about where your product team has evolved to. It sounds like one is really understanding the full landscape of requirements. So, understanding that the customer has, some set of needs, but there are also regulatory compliance needs, that kind of
Yep.
thing. What are some of the other things that really jump out at you as the team is iterated to something that works well?
I think some of it honestly is just, we've been working together for a little while. So my team has been an enterprise function since about the beginning, I would say, of 2022. So we're close to 2 years, right? So as an
Hmm.
enterprise tooling team. And so I think that some of it is just time and experience working together and
Hmm.
having the opportunity to make some mistakes and come back from those mistakes and understand like what's the best engagement strategy with our customers and how can we meet them where they are, listen to them, all of these things. And so I think there's not really a magic bullet. I think we've landed in the right place, just I think through time and hard work. And I think the other thing I'll say is that now that we've been around for a little while, our tools are starting to spread and gain more usage, right? And so one of the things that Ali and his product partner Abby often say is we want to incentivize through ease of use. Like ultimately at the
Mm.
end of the day, if we're building things that are bad or not useful, people are not going to use them and they shouldn't use them, right? Like if I build something that's terrible, you should not use it. You should use something else. And so we try to keep that in mind, as we work with our product team. And so I think it's really just building good software. It's just like there's no substitute for hard work either. And how we're starting to have success is just through all of those things. There's not any type of magic bullet.
Awesome. Awesome. Well, Miriam, it is always a pleasure connecting with you and hearing your take on the world of data science and ML and AI in Capital One. Um, Thanks so much for joining us.
Yeah, thanks so much for having me, Sam. It's always great to talk to you as well.